This is a lecture from OpenTuition. To benefit from the lecture, you should download the free lecture notes from opentuition.com.
In the previous lecture, we looked at adding on interest, which is called compounding. In this lecture, in a sense, we're doing it backwards, as you'll see, and we call it discounting. And as always, to explain what I mean and the sort of things you can be asked, look at the examples. First of all, example 5. What amount now is equivalent to $800 in 4 years' time if there's interest at 10% a year? So it's effectively saying, to end up with 800 in 4 years, how much would I have to put in the bank now? Well, if the amount was P, you already know from what we did before that if you put P now, then every year we add on interest at 10%, we multiply by 1.1, and if it's for 4 years, it would be times 1.1 to the power 4. Now, we want it to have grown to a terminal value of 800, and so it's simply working backwards. P is 800 divided by or multiplied by 1 over 1.10 to the power 4. And so divide by 1.104 times. And we get, oh dear, it keeps doing this, 546. So 546 now would grow to 800 at the end of 4 years. And we call that 546 the present value. Now, although that wasn't, I hope, not hard, it was just doing what we did before, because this is such a common exercise, it's really in the next chapter you'll see why it's so common and so important, that you are given tables to save the arithmetic. We took 800. Now, although I'm dividing by 1.10 to the 4, you may think it a bit funny, I've written this multiplied by 1 over, but it's the same thing. The figure we multiply by is called the discount factor. And the exercise, the whole thing, is called discounting. If I can fit it in. Now, as I say, although that's not particularly hard, dividing by 1.14 times, if it was 15 years, you're going to be messing around with your calculator for ages. And so, as I said, you are given tables, and if you turn to the tables at the front of the lecture notes, there are actually 2, and I'll tell you what the other one's for later. But make sure you're on the one that says present value table. And that table gives you, along the columns, for any rate of interest up to 20%, and down the rows for any number of years up to 15. It gives you the number to multiply by the discount factor. So here, instead of multiplying by 1 over 1.1 to the power 4, if you look on these tables at the 10% column, because it's 10% interest, and if you look at the 4-year row, you'll see 0.683. And that is 1 over 1.10 to the power 4, but it's calculated for you. And if we multiply 800 times 0.683, I get 546.4. What's the nearest dollar? 546. Now, incidentally, these tables are rounded to 3 decimal places. So occasionally it could be slightly different than if you'd done it by hand. But I expect to use the tables in the exam, and it's so much quicker, of course. It is 1 over 1.10 to the power 4, but these tables have worked it out for you. So just check the next one. Example 6. What's the present value of 1,200 receivable in 12 years' time with interest at 13%? Well, again, you could do it first principles. Divide by or multiply by 1 over 1.13, 13% to the power 12 years. But however good you are with your calculator, why mess around? From the tables, it's the 13% column, the 12-year row, so check you've found it, 13% column, 12-year row, 0.231. Again, that's the discount factor. And therefore the amount we'd need to put on deposit now to have grown to 1,200, 1,200 times 0.231, 277.2. But usually, it'll be clear from the question, but usually leave it to the nearest dollar. Oh, which is remarkable, really. You put 277 on deposit for 12 years at 13%, and at the end of 12 years, it'll have grown to 1,200. There is the present value. So, I think that's easy enough. I hope it is anyway. Let's have a look, though, at the next one. Make it a bit more interesting. Something called an annuity. Now, the definition of annuity, it's an equal amount each year. And you'll see a great big formula there, which is on the formula sheet, but you don't actually need. Look straight to the example, example 7. The interest rate is 12% a year. He says, what's the present value of 500 receivable in 1 year's time, and thereafter every year for a total of 8 receipts? So this time we're getting 800 in 1 year, 800 in 2 years, 800 in 3 years, and so on, 800 in 8 years. Except it's not 800, it's 500. Well, now I got for 8, but still. And he wants the present value. Well, we could do each one separately. It's 12%. And so you could say, well, from the tables, the discount factor for 1 year at 12%, 12% column 1 year row is 0.893. For 2 years, it's 0.797. 3 years, 0.712. 8 years, 0.4, oh dear. 893.78. 893.797. 712. 8 years, 0.404. You could go through them all, multiply them all up, and add up. Which is all a bit messy. However, because annuities are quite common, equal amounts each year, instead of having to discount each year and then add them up, there are tables that give you the total of all the discount factors. And we can simply multiply 500 by the total of them all. And that's what the other tables are. The annuity tables, they give you the total discount factor for any number of years up to 15, any rate of interest up to 20%, and it just makes it a hell of a lot quicker. Now this example, instead of listing 500 8 times, the shorthand is we say it's 1 to 8. It's 500 in 1 year, 2 year, 3 year, 4 year, up to 8 years. Per annum, per year. And instead of discounting each one separately and adding them up, we simply look for the 8-year annuity factor. What was the rate of interest? It was 12%. 8 years at 12%. Make sure you're on the right tables, the annuity tables. 12%, 8 years. I get 4.968. And what that is, it's the total of the individual factors on the other tables, the total for 1 year, 2 year, 3 year, 4 year, 5 year, up to 8 years. By all means, check them. That's a bit of fun for you later in the day. Check the annuity tables by adding up the factors on the other tables. However, as a result, the present value, 500 times 4.968, is 2484. So individual amounts, an amount in 1 year or an amount in 5 years, we multiply by the ordinary present value factor. If we have an annuity, an equal amount each year, we multiply by the total or the annuity factor. However, before I leave annuities, there is one, what you might call trick to watch out for. The annuity factors from the tables, that gives us the total for any number of years from 1 onwards. So it can give us a total for years 1 to 8. It'll give the total for years 1 to 5, years 1 to 15, and so on. But the little trick, look at example 5. Sorry, I'm on the wrong example. Example 8. I've lost my page. Example 8. A man expects to receive 1,000 in each of 9 years, with the first receipt being in 4 years' time. So the first receipt's in 4 years' time, and it's then each year, so it's 4 years, 5 years, 6 years, 7 years, and so on. Check your numbers carefully. I know this sounds stupid, but I use my fingers. He's going to receive it for each of 9 years, so 4, 5, 6, 7, 8, 9, 10, 11, 12. The last receipt will be in 12 years' time. So again, instead of listing them 4 years, 5 years, 6 years, and so on, the shorthand 4 to 12, the first receipt is in 4 years' time. It's every year. The last receipt is in 12 years' time. And the amount is 1,000 each year. Well, it is an annuity, an equal amount each year. But our little problem is the annuity tables will give us the total for any number of years, but always year 1 onwards. It won't give us a total straight from 4 to 12. And so what we have to do is this, a little bit of workings. I can get the total for 1 to 12. That's the 12-year annuity factor, and the rate of interest here is 8%. So the 8% column, the 12-year row, the total is 7.536. Now, this is the bit that's coming to be careful of. It's where people make a silly mistake. That is the total for years 1 up to 12. I only want the total for years 4 to 12. And so since I've got the total for 1 to 12, we subtract the total for the first 3. If I subtract the total for the first 3 years, I am left with what I want, 4 to 12. And of course, I can look up the total from 1 to 3. I can look up for any number of years from 1 onwards. And so at 8%, the 3-year row is 2.577. There's the total for years 1 to 3. And if I subtract that, the figure I'm left with, 7.536 minus 2.577, 4.959. That is the total of the factors for 4 to 12. And now I can multiply as usual, and the present value, 4959. So there are annuities. Finally, though, what you might call the ultimate annuity, perpetuity. Now, what a perpetuity is, it's like an annuity. It's an equal amount each year, but instead of being for 5 years, for 10 years, for 15 years, it's an equal amount each year forever. Now, of course, nothing lasts forever, but for so long as it might as well be forever. And to make sense of it, look at the example, if I can find it. All my pieces of paper are going all over the place. The last example, I think it's example 10, isn't it? Annuities. Here we are, perpetuity. It's example 9, sorry. The interest rate is 12%. What is the present value of 5,000 receivable in 1 year's time and thereafter in perpetuity? So again, it's 5,000 a year. First received in 1 year's time, but instead of, as I said, instead of being 1 to 5, 1 to 10, it's forever. We write it as 1 to infinity. Now, this is the one place where you haven't got tables. You've already seen if it's just one amount in 5 years' time, use the present value factors. If it's an equal amount each year for 5 years, 10 years, use your annuity factors. For a perpetuity, you don't get tables, there's a formula. You multiply by, I'll explain why in a minute, you multiply by 1 over R, where R is the rate of interest. And so let's do it for this example before I explain why it is. 1 over R, it's 12%, so 1 over 0.12. And multiplying by 1 over 0.12 is the same as dividing by 0.12. 5,000 divided by 0.12. Is it right? 5,000 divided by 0.12. Yes, it is 41,667 to the nearest dollar. So that's the one bit you've got to learn, but that is an easy formula, 1 over R. If you're wondering why, I mean, the exam you don't wonder, you just do it. What it is just suppose you were my wife and we've got divorced. And the courts say, I've got to pay you 5,000 a year for the rest of my life. Well, I don't want to keep messing around paying you 5,000 a year. I'd rather forget you completely. And I see that the banks are paying 12% interest. So I'll say, if I put 41,000 in the bank, I can then forget U completely, because at 12% interest, 41,667 times 12%, 0.12, that will give you 5,000 a year forever. And how did I know? I said, oh, I want it to get 5,000 a year. The interest is 12%. I sort of worked backwards. Anyway, I don't care. I mean, a rule's a rule, but it's nice to see the logic. So there are the 3 bits of discounting you can be asked. I know I've already said it, but an individual cash flow, if it's just 5,000 in 3 years' time, you use the present value tables. If it's an equal amount each year, an annuity for a fixed number of years, you use the annuity tables. If the least common, but if it's an equal amount a year forever, you multiply by 1 over the rate of interest. All right, so there are the rules for interest, for compounding, and more importantly for discounting. In the final chapter of the notes, we'll look at how we can use that for what we call investment appraisal.